Hi, welcome to the flipped instructional session for Math 08A for Unit 302, Equations in Two Variables. Our objectives today are to determine whether an ordered pair is a solution to an equation in two variables and to make a table of ordered pairs to graph a line. So in Unit 2, we talked about solving an equation with one variable. Today, we're going to talk about a solution when the equation has two variables. And we're also going to show how that will be used to graph a line. So units 3, 4, 5, and a little bit of 6, if I'm remembering correctly, about 6, all deal with lines. So this is something that we want to get a good understanding of as we get started. So there's a lot of new definitions that we need to know. Something that we really are going to focus on today are ordered pair. So an ordered pair comes in the form with the x-coordinate and the y-coordinate, and that refers to locations on a coordinate plane. So for example, this spot right here has the ordered pair 3, 2, because it's 3 over and up 2. We always read the x-axis and then the y-axis. Let's call this point A. Point B down here is -4, -3. So the ordered pair are these coordinates. And what we're going to find is when we have a line, so for example, this line, any ordered pair that falls on this line, which has infinite ordered pairs, it keeps going on and on and on, any ordered pair that falls on this line is a solution. So we're going to check on all of that today. Just a review from Unit 2, x minus 8 equals 19. We want to solve for x by using an inverse operation. So plus 8 to both sides. -8 plus 8 cancel, so x equals 27. So that's a little review from Unit 2. So this asks us to match the ordered pair to the correct choice, so yes or no, to see if it's a solution to 2x plus 3y equals 3. So we just look at this equation. We can't just solve it to get an x equals a number because we have an x and a y, and these are not alike, so we can't combine them. So this is starting to show us that math has a lot of different kinds of solutions, not just x equals a number. In this case, we're going to see if an ordered pair works. And like I showed you on the previous slide, there are infinite ordered pairs that work when we have x and y. We just need to find some of them. So what this is telling us is, remember ordered pairs x, y. We're going to plug in 1 for x. And then we're going to plug in -1 for y. So we have 2 times 1 plus 3 times -1 equals 3. 2 times 1 is 2. 3 times -1 is -3. We end up with -1 equals 3. Well, that's a big fat no. What this means is the ordered pair 1, -1 would not be on this line. So we have a line we look for 1, -1, which would be right here. We see that this is not on this line. So we're just trying to find if these specific ordered pairs would be on this line. I just drew this line, so we'll see. So let's take a look at the next one. So now they've given us the ordered pair 2, 1. So the 1, I'm just going to highlight down here. So let's see here. We have, oops, not 3. All right, so this time we're plugging in 2, 1. So 2 times 2 plus 3 times 1. We get 4 plus 3. So we get 7 equals 3, which is no. And if I look at 2, 1 on my graph, I'm seeing that's also not going to work anyway. So maybe my graph is somewhat right. Let's do the last one. Now remember, all 3 of these could have been yes. There's not just one ordered pair. As long as the ordered pair is somewhere on this line, the answer is yes. So 2 times 3 plus 3 times -1 equals 3. So 6 minus 3. So 3 equals 3. Finally, we get a yes. So look, 1, 2, 3, -1. There it is. My graph was actually right. So that fell on this line, and so it is a solution. But remember, there's not just one solution. All of these ordered pairs on here are a solution. What equation can be used to determine whether 3, 5 is a solution to 3x minus 4? So this is just another way for them to write out. We're just going to plug in wherever we see. So we just need to make sure we know that x comes first. So 3 times 3 minus 5 equals 4. 9 minus 5 equals 4. 4 equals 4. So this is a solution. 3, 5 would be on the line 3x minus y equals 4. Now, if we need to make a table of values, I'm actually gonna, if we needed to make a table of values, we can choose any values we want, plug it in, and find the other value and get the ordered pair. So we're going to pick x values. I like to pick 0. We can pick any values we want. So let's say they wanted 4 ordered pairs. We just plug it in for x. Just like we did before. We don't have a y. We're going to find it. Two times 0 is 0. 0 plus 4 is 4. So this ordered pair is 0, 4, and that would be on this line. So if we're making a table of values, that's how we would do it. So now I plugged in 1. 2 times 1 is 2, plus 4 is 6. So the ordered pair is 1, 6. 2 times 2 is 4, plus 4 is 8. So 2, 8. 2 times 3 is 6, plus 4 is 10. So I found 4 ordered pairs making a table for this line. I'm going to show you one more. If you have a fraction with your x, which will happen more times than not, and you're supposed to make a table of values to find 4 ordered pairs, I still always pick 0, but you want to pick numbers that when multiplied by 1/3 gives you a workable number. So you want to pick multiples of the denominator. So 3, 6, 9. If this was 1/4, you'd pick 4, 8, 12. If it was 1/2, you could pick 2, 4, 6. So you want to pick multiples of the denominator. So you'll see why here in just a second. 0 always will work, because 0 times anything is 0. So now I'm just plugging in for x. We're going to solve for y and make our ordered pair. 1/3 times 0 is just 0. So y equals 5. That one's always easy. 1/3 times 3 is 1 because these cancel out. They reduce. 1 plus 5 is 6. 1/3 times 6. This reduces. So 2 plus 5. So this is making the math easy because 3 and 9, this is going to reduce. So I get 3 plus 5. So that's why you want to pick multiples of the denominator. And so I've made a table of values to find ordered pairs, which we could eventually graph. And when we graph it, it makes a line. So this is kind of foreshadowing what's coming, but it's something important that I just wanted to show you while we're plugging in values. So check your Class Connect schedule for the Flip follow-up and help lab. I look forward to seeing you there. Thanks.